This is a video from section 8.3. The directions say the following. Point masses m sub I are located on the x-axis as shown. Find the moment capital M of the system about the origin and center of mass x bar. And with that, we're going to take a look at problem number 21. So notice in 21, we're given the x1 equals 10, x sub 2 equals 30. So the corresponding mass for x sub 1 equals 10 is 6, and the corresponding mass for x sub 2 equals 30 is 9. So the moment capital M about the origin is given by m sub 1 x sub 1 plus m sub 2 x sub 2, which is equal to 6 times 10 plus 9 times 30, which is equal to 60 plus 270, which is equal to 330. X bar, my center of mass, is m1 x1 plus m2 x2 divided by m1 plus m2. So, in other words, it's the moment about the origin divided by the sum of the masses. And so, if I substitute in my values, I get 330 divided by 15, which is equal to 22. That's problem 21. Let's look at the directions for problem 23. The masses m sub I are located at the points p sub I. Find the moments m sub x and m sub y and the center of mass. So for the point 31, the corresponding mass is 5. For the point 04, the corresponding mass is 8. And for the point -5, -2, the corresponding mass is 7. Okay, so the first step, we want to find m sub x. That's defined as m1 y1 plus m2 y2 plus m3 y3. And so what I do is I go to the previous page and I notice m1, m2, and m3 are given to me. So m1 is 5, m2 is 8, m3 is 7, right? And so if you notice, I'm trying to find m sub x first. And so what that means is I need the second coordinate of each point. And so I look at the second coordinate for the first point, that's 1. The second coordinate for the second point is 4, and the second coordinate for the third point is -2. And so I just write those down. So notice that y sub 1 is 1, y sub 2 is 4, and y sub 3 is -2. And then I just put everything together. So this is 5 times 1 plus 8 times 4 plus 7 times -2. This is equal to 5 plus 32 minus 14, which is equal to 23. M sub y is m1 x1 plus m2 x2 plus m3 x3. So if you notice over here, I do pretty much a similar thing, right? I list out all my masses. So notice that m1 is 5, m2 is 8, m3 is 7. The only difference is I need to look at the first coordinate of each point. So x1 is 3, x2 is 0, and x3 is -5. And that's all I did. And now I start to put it together. So m sub y is 5 times 3 plus 8 times 0 plus 7 times -5. So this is 15 minus 35, which is -20. The masses m, right, little m, is m1 plus m2 plus m3, which is 5 plus 8 plus 7, which is equal to 20. So x bar is equal to my over m, which is -20 divided by 20, which is -1. Y bar is mx over m, which is 23 divided by 20. And you could either leave it as 23 over 20, or we could write this as 1.15, the decimal equivalent. Either way is okay. And so my center of mass will in fact be the ordered pair -1, 23 over 20, which can also be written as -1, 1.15. And if we go back, we're going to go over -1 and down, well, in this case, actually, we're going to go up 1.15, which is going to make it about here, roughly speaking, just a little bit above 1. And that's where the center of mass will be located given these ordered pairs and corresponding masses. Okay, that'll conclude this video for section 8.3, and we looked at problems 21 and 23. Thank you.